Hello, in this video, I am going to introduce you to the basic techniques of estimating measurement errors. So this will guide you on performing a reliable data analysis for your future lab reports. So, what are measurement errors? Of course, when we do measurements, say we measure the length of a pencil using a ruler, or maybe we measure the resistance of an electrical component, it is not possible for us to obtain the true value for such measurements. In other words, when we measure something, there's always uncertainties. All measuring devices have their own precision. For example, a wall clock's precision is up to 1 second. Also, a wall clock cannot tell you any readings within 1 second interval. Next, for a standard ruler, its precision is up to 1 millimeter, and it cannot tell any reading within 1 millimeter interval. A non-fluctuating device is a device that doesn't give fluctuating readings. This type of device includes the rulers, thermometers, and etc. Measuring from a non-fluctuating device requires the following steps. Firstly, you record the displayed value. Next, you determine the smallest resolution of the device. For instance, a standard ruler may have a 1 mm resolution. So, we say the delta X is 1 mm. Finally, we quote the measurements as the reading plus minus delta X divided by 2. Here, the measurement error is given by half of the device's resolution. Suppose that we want to measure the length of a pencil as shown in the following figure. Intuitively, the length of the pencil is 5.2 cm. However, the tip of the pencil lies between 5.2 cm to 5.3 cm. So again, we are uncertain. Therefore, the measurement error is given by 1 mm divided by 2, which is equals to 0.05 cm. Finally, the length of the pencil is 5.2 plus minus 0.05 cm. Now, take a look at the following photometer. As you can see, the photocurrent I is fluctuating over time. In other words, it displays constantly changing numbers, and the true measurement value is not known. So, measuring using a fluctuating device requires the following steps. Firstly, you randomly select n sample readings from the device. Then, you calculate the sample mean. Next, you calculate the sample standard deviation, and finally, you quote the measurement as the mean of the reading plus minus the standard deviation of the reading divided by the square root of n. So, whenever you have problems with fluctuating reading, please remember these steps. For example, suppose that I have randomly taken 5 measurement values from the fluctuating photometer. Firstly, I calculate the average of these 5 measurements, which is 49.761 picoampere. And then, I calculate the sample standard deviation. I got 0.215 picoampere. Next, the measurement error is given by the sample standard deviation divided by the square root of 5, and I got 0.0961 picoampere. Finally, I quote the reading as 49.761 plus minus 0.0961 picoampere. In conclusion, please remember to include the error of your measurements. It helps a lot when you do your future data analysis.